not a step back, but just a little bit of step to talk about relations and functions and how they are going to correlate with each other's. And it's going to refer to domains and ranges. Have you guys ever seen a mapping? It's two sets of circles like this. And over in this first circle, I'm going to have the domain. And in this circle, I'm going to have the range. And if I have a set of numbers that look like this, I'm going to put all of my x coordinates over here. 1, 2, 3, and 7. And I'm going to put my y coordinates over here, but if they're used twice, I'm only going to list them once. So I have this 5, this 6, and this 15. So the mapping says that you go from one domain to one point in the range. 2 also points to 5. So 1 points to 5 and 2 points to 5. 3 points to 6 and 7 points to 15. So a function occurs when a number in the domain only points to one number in the range. So basically, when you're looking at some mapping like this, if this number has one arrow coming out of it and pointing over to a number in the range, we have a function. Here's one that points. It points from 3 to 6, 7 to 15. Each one of these numbers only has one arrow coming out of it. So when that happens, this relation is a function. It doesn't matter that 2 arrows go into 5. We're only worried about whether or not only one arrow comes out of the domain. And the reason for that is a function says you can only have one specific range or one y value for each of your x's that you have. So when I plot these points, 1, 5, 2, 6, 2, 5, gotta erase that one, 3, 6, and 7, 15. Okay. What you want to happen is if you were to place a vertical line, I'm going to see if I can do this way. Let me move some of these. Okay, so I have a vertical line here now. If I take that line and I move it, anytime that I move it across the X as I go from left to right, I'm only running into one point at a time. This is called the vertical line test for a function. I only hit that one point as you take a vertical line and you move across the x-axis. So if I only hit one point, it's a function. Unlike this set of numbers. If I look at this in terms of a mapping arrangement, I have a 0, I have a 1, I have a 2, and I have another 1. In my range, I have a 5, a 6, an 8, and a -2. So when I go from 0 to 5, there's one arrow, 1 to 6, there's one arrow, 2 to 8, one arrow, but then I have to come back up here and map another 1 with a 2. So when I get this situation where I have 2 arrows coming out of one value in the domain, only in the domain, this is not a function. And if we look at the graph of those, we'll see so if I take that vertical line now of mine and I move it along the x-axis, I hit one point that's in my set, and at this point I'm hitting 2 different points. I hit a point down here and a point up there if my graph was drawn correctly. Okay. But then as I move, I'm only hitting one here. But anytime you have a vertical line that hits 2 different points, it's not going to be a function. This is called the vertical line test. So if you can move a vertical line across and hit 2 places, you do not have a function. In terms of mapping, if you look at the x coordinate or the domain, if you have one domain that has 2 arrows coming out of it, it's not going to be a function either. So those are 2 ways to say whether or not you have a function. Questions on that?
So are we just graphing the equation and then figuring out if the line touches? I'm not completely understanding.
Right now we're trying to decide whether or not a relation is a function or not. Given these points, we're just trying to see, is there a distinction between just a relationship like this one down here? They relate the x's to the y's. They have an x that goes with a y. That's a relation. But up here, this relation of ordered pairs is a special type of relationship. It's a function because it doesn't have any x values that repeat with a different y value. So one of the ways you can tell is by using this vertical line test. The other way to tell it is by looking at the mapping and seeing if you have a double arrow coming out. Okay? Does that clarify anything
And
or
if
not?
you do, would that not be a function?
Yeah. If you fail the vertical line test or you fail the double arrow test of the two values coming out of the domain, then it's not a function.
Okay.
Like in this case up here, we had 2 arrows coming into the 5. That doesn't matter. It doesn't matter how many arrows go into the range. It depends on how many arrows come out of the domain. If there's more than 1 arrow coming out of the domain, it's not a function. Okay, any other questions? Okay, so I'm going to have you work on just the inquiry lab, and that's what we're looking at with the inquiry lab. So if we, I don't know, you guys have your books there or not, but on page 285 and 286, mainly 286, there's 3 problems that I want you to do for your homework tonight, and that's it. So it's going to be just those 3 problems, and it's not using the vertical line test, it's just using the mapping, the domain and the range mapping here. So you can have people's names as a domain. So on page 286, the first chart starts out and it says a student, and it gives their specific names. So you have 4 different students, Sarah, Max, Jacob, and Rebecca. Those would go in your domain. And in your range, you would have the 275, the 220, the 350, the 275.
I have a question. Are we just doing page 286, 1 through 3?
Well, actually 1 through 3, because I already told you the answer to number 4. Okay, so it's just 1 through 3 on that page. So,
and do we have to worry about number 285?
You don't. That was, if you want to refer back to that you can refer back to that. Back to their examples on 285. Okay, so 286, 3 problems. It's an important lesson to learn about domain and range and how you can tell the difference between them. Okay?
Thank
All right.
you.